Hello guys. Today we'll be talking about KCL, Kirchoffs current law, and Ohm's law, and we'll use those two to solve a problem. And I'm gonna show you a problem, and I'll work through it. So let's just do it first. I'm gonna draw the schematic. R1. There's another resistor here, 2 ohms. There's another R2. And another resistor here, R3. Okay, and here we have ground, and there's 2 amps flowing this way, and here there's 4 amps flowing that way, and the voltage here is negative 10 volts. And the objective here is to find R2, the resistance 2, and R3, and we can only use KCL and Ohm's law. Okay, so first of all, what we can do is we can just look at this node right here, and what we can do is we can use we can do KCL on that node. So, or let's just say V on V. Okay, I'm just labeling that as V. So so the KCL here will be first, let's just label this as I3, and this as current flowing through this node as I2, and this as I1. This is I1. So okay, so whenever you're doing KCL on a point, always remember that the current leaving the node is always negative. So and the current going through is always positive. So this is going through, so it's positive, I3, and I2 is also going through the node, so it's positive. But as you can see, the 4 amps is leaving, so it's negative. So I1 is negative. So and it's equal to 0. As we all know, KCL, the current entering, the sum of the current entering and the sum of the minus the current exiting is equal to 0. So we know I3, we don't know I3, we know I2, which is 2, and we know I1, which is 4, equals to 0. So I3 equals to negative minus 2 equals 0, I3 equals to 2 amps. So we know the current through this branch is 2 amps. Okay, now we can use Ohm's law, which is V equals IR, to solve for the resistance. So as you can see, the voltage at this point is negative 10 volts, right? And what that means is the voltage in a circuit is measured from the ground. So so the potential difference from here and this point is negative 10, and the only component between those two is this resistor. So that means the voltage across this resistor is also 10. So we can use this to solve for R2, because R1 is in parallel with R2, which means and we know that parallel components have the same voltage. So R1 and R2 has the same voltage. So in order to solve for R2, we can do V2 over I2, and we know that or it's actually I labeled as I3, but it doesn't really matter. But V2 is 10 volts and I is 2, so R2 will be 5 ohms. And to solve for R3, it's the same thing, because R3 is also in parallel with R1. So if the voltage in R1 is 10 volts, it's the same in R3. So R3 will also be V equals V over R, and that's 10 over, and it's also 2 ampere. The current is also 2 ampere in this branch, as you can see it's labeled here already. So it's 2, and that will also be 5 ohms. So yeah, that's how you solve R2 and R3.